Thanks a lot, Bastian, and thanks for the invitation. It's the pleasure for me and Henny to present the work we did and how we got to produce the textbook on hydrological drought. We focus on two aspects, both, as it says in the subtitle, like the knowledge we gained from working in this international collaborating effort with the many co-authors, and also we will share some key aspects of the content of the content of the book and the individual chapters. I'd like just to start with showing this picture, which is called the Hunger Stone. It's in the River Elbe. It was sort of rediscovered during the drought in 2018 that hit northern and central Europe. So we're very familiar with seeing these flood marks and these stones being carved with a very high water level. But then this is the low flow mark. So you need to lay on this stone and read then what's now upside down. And if you can read, you will see written in German and translated to English that when you see me, then you will cry, because this was a warning sign of drought and famine. So there are these low flow marks and mainly in Eastern Europe. I'm not so familiar with other continents. So with this, get to see if I get it to change pages. So the outline of the talk today, we start with the motivation for compiling the textbook. Henny will give it in detailed about the process of how we got there from the start, then the book structure, and then we will do chapter presentations, 2 to 3 slides on each chapter, where we will give the motivation, some key content and message on each, and then some concluding remarks to the end. So starting off with the motivation, we have to go a little bit back to the first edition of the book. It was published in 2004 and came as a result of an EU project that many of us within the EuroFriend group were taking part in. And we realized then it was, we started in 2002, and then this major drought event came in 2003 in Europe. So we really was very good in the timing of the book. And we realized when we started working on droughts, there were very limited textbook literature. You had to go to individual papers. So we decided to compile a textbook. By having it as an EU project, we had the consortium was defined beforehand. So it was those of us who took part in that project. And we had, through this project, many iterations. We got feedbacks on early drafts. We had expert meetings. We had a little bit of a Northern European bias in the authorship. We had an expert meeting with operational hydrologists from the Mediterranean region. We also had other friend members, not part of the author team, reviewing the draft. We had a separate workshop with users, stakeholders, which was very valuable in terms of giving us feedback. And we organized an international study course for advanced students, also based on the early drafts. So then we could revise on the way based on their feedback. So after some years, it got out of stock, and it was then another few years before we were contacted by Elsevier, who published the first edition, whether we will be interested in making a second edition. And we have been trying, when it got out of stock, to make it the first edition available free online, and Elsevier always said no. So then negotiated we will do a second edition, but that under prerequisite that the first edition can be available online. So it is available on the EDC, European Drought Center website. I just have a screenshot here under resources. You will find the book and each chapter as a PDF. And you notice also it says software next to it. So originally the book came with a CD with data and software and worked examples. And then we decided to put that online along with the book. So then the first initiative for the second edition was taken back in 2016, and Henny will later guide us through that process. We compiled some statistics based on how many times it's downloaded, the first edition. I didn't manage to get an update, so this is from 2018, a bit dated. But we see several hundred downloads, and more than 50 countries have downloaded it. And you see this pie chart giving the distribution among the 19 most top countries who has downloaded it. And we regular, more or less every week, get a notification that it's been downloaded again. So that's very encouragement for us. And some of the chapters haven't changed that much. I'll come back to that. So when we started thinking about and had the invitation to do a second edition, we realized it could not just be an update on review of recent or more recent works, but it also had to include new content. So we see it as quite a major change from the first edition, because there are new authors on the team, and some have retired and not part of this. And then we were not part of a bigger project, so we had to recreate the consortium, inviting new authors in. And mainly, again, we worked with people we knew from the FRIEND network. So the aim of this, if we like to formulate the aim of the second edition, was that we would like to increase knowledge and awareness of drought to a wide audience, and then hopefully encourage many drought studies around the world. And then, of course, the basic motivation is to provide a comprehensive overview of methods and tools that can be used to estimate and manage hydrological drought. So it's readership that goes for both editions. It's meant for university students, lecturers, practicing hydrologists, researchers who are engaged in the analysis of hydrological drought and its prediction. As I said, majority of authors are from Europe and members of FRIEND, but we try to broaden out and include experience and some authors from region outside Europe. So as we knew when we accepted to do a second edition, we knew it would be a demanding task. So if you see the motivation that we went through or thought about was, of course, that the textbook had got a bit dated. You had to go to the website to get it. And then the response to it being dated was that we did an update review of literature since the original one was published. And then there had been major developments in the field with new content was needed. So the response was, first of all, to do this review, update the knowledge, and make it available to a broad community. So we needed to update the author team. We created a team of drought experts. We're covering a very wide range of field, a bit wider than the original one. And we're learning from each other as part of this process. So there's a cross-learning from college across the chapters that we were responsible for. As a motivation, we saw that the increase in drought work studies being published, we saw that there's a number of new approaches being published and suggested, and it has just grown massively. So it's becoming very hard to do comparative analysis and to provide robust conclusion, as there's so a variety of indices and way of analyzing drought, hydrological drought, than in particular. So we thought our response and motivation would be to help navigate and provide recommendations when applying drought knowledge and tools to sort of navigate within this massive new studies on drought. So I leave then the word to Henny.
Okay, thank you, Lina. I will dig in a little bit in the process and the timeline. As Lina said, the main aim of the book was actually to increase the knowledge and awareness and to provide a comprehensive overview of methods and tools. But the other big challenge was to do it actually in a very consistent way. So what we introduced with the team of authors, the chapter structure. So there was a template we introduced where we actually had the chapter structure, an abstract keywords. Actually, there was a sequence ending with references. What we also did, we had discussions about terminology, and at the end, not at the end actually, but at the end, we had the final one. We developed a glossary, so that's also in the book. And we discussed cross-referencing so that the chapters are connected, and we decided actually also have to forward referencing. And in addition, the book provides at the start or at the end abbreviations. So there is pages with abbreviation symbols. So we have tried to do that consistently through the book index terms. That was actually done by Elsevier, but we had a lot of comments on it. This was a kind of an automated procedure and a number of appendices in the book. So we decided to have an updated Kappa-Geiger classification and probability distributions and top creating things which were a little bit too detailed in the book are actually added to the appendices. And a strong thing in the book is worked examples where we that actually readers can actually practice and text boxes to explain. And there is pages, hundreds of references in total in the book on the end of each chapter. But we actually started every chapter with a number of key references, 4 or 5, so that people quickly could actually be introduced in the subject. The book in total, you can see the number there, 684 pages. It's even more. There are tens of papers at the beginning, a Roman number. So in total, it's over 700 pages. It was when we finally actually had the author team. It consisted of 32 authors, and from there were 11 lead authors, and then Lena and me were the 2 editors. So it was a major concerted team effort to get actually this in a consistent way. Yep, next slide. In the abstract, you could read that we thought that it was a 5-year book project, but when we looked at the details, it appeared to be an 8-year book project. So, as Lien already said, we got an invitation from Elsevier, and that was in October 2016. And then we finally published the book in September 2023. So almost 8 years and not 5 years as mentioned in the book. So as editors, we had to interact with Elsevier as a publisher. So they actually provided the guidance for authors and the Elsevier management submission system. And we thought it an advantage rather than do it ourselves like we did in 2004 with a camera-ready production. In a few seconds, we'll come back. That was not really a complete success to do that with the Elsevier management submission system. And of course, we had the interaction with the lead authors, which started a little bit later at EGU in 2017. Next slide, please. Okay, what I will do is cut down the timeline, give a little bit more of detail. So the first period was in 2016, 2019. And it started actually with the contact with Elsevier. So then you got the invitation, and then you have a book proposal. So that's a formal procedure, and then it was reviewed by 3 reviewers. We got an approval, and then the contract negotiation started. And as Lita said, it was a little bit tough, particularly the negotiations to get the copyright back from the first version. That was for us a prerequisite, and that took almost 1.5 years, these negotiations. And of course, we got guidance for authors from Elsevier. Interesting to see that we put in the contract the delivery date at December 2019. So that was a bit ambitious. Next slides. So this is the interaction in the same period, a little bit later. Formally, we started at EGU 2017, and there were multiple meetings actually. So back-to-back meetings. Usually, as Lena said, we didn't have financial resources. So what we usually did is at the EGU or at an IAHS meeting in Utrecht, or we had a FRIEND-Water meeting in Freiburg. So then we had contact with the author team or with individual authors. So we worked that on we started with the anticipated content and actually identified in the beginning the authors and who would like to contribute these kind of things. And we started to write. So that was what we did in this period. One particular meeting, the Drøbak meeting, next slide, Lena, that's here is a photo of this meeting in Norway. That was a writing retreat. What we did actually, we had in early 2019, we had outlines of every chapter. There was a first draft of almost every chapter and there were discussion points. So we discussed chapter by chapter. We discussed the book and we identified actually also cross-referencing where is overlap, where to put what, where in which chapter. So it was a very fruitful meeting, also very enjoyable. So this was good for the team spirit and the team building. We cooked our own meals and it was January, so there was snow in Drøbak, so that was really enjoyable meeting, but also really important to actually for the book itself, and particularly also the team building, so that you work together and to try to produce this coherent consistent book. Next slide. So then we move on to the second time block. As I said, we planned originally to finish the book in the end of 2019. Already in summer 2019, we already knew that we wouldn't manage to do that in 2019. So there was already a postponement of the delivery to summer 2020. But then suddenly dramatic things happened. That was COVID-19, Corona, so that dramatically changed our life as a professional and also private life. So there was no physical face-to-face meeting anymore. So there was no silence. So what we did actually, there was activity. There was drafting of chapters. There was reviewing of chapters because all chapters were reviewed by the two of us. So two reviews, and then most of chapters were reviewed at least by one, but some of them were really reviewed by two reviewers. So that the reviewers came from the lead author team. So they took the responsibility to review also chapters. So in total, the chapters are reviewed by 3 or 4 persons. Practice with the Elsevier management submission system. So that was also a bit hard to get started, particularly to get the authorization, also the strict rules from Elsevier. And we had online meetings, very regular in this 2.5 years. And I have to admit, there was regularly there came emails from Elsevier to remind us to finish the book, which was really difficult in this very dramatic period with a huge impact on our private lives. So the next slide, and that's the last time block. That was mid-22. In mid-22, in most countries, all the measures were actually gone for COVID, so we could actually live a little bit more free and life was a bit more easier. So if we look to the timeline, then we saw that in November 2022, all chapters were submitted in the electronic management support system. And then we thought, okay, then it is very quickly over and we will have the book by the end of 22 or early 23. But then the e-proofs came. That was around Christmas 22. Then Elsevier actually tried to convince us that we had to do that in the Christmas break, the authors and the editors, and of course we refused that. But the authors finally managed to review their chapters in February 23, so early 23. But then we had as editors, we had a little shock actually when we looked at the chapters in more detail. That first we had to work on the index, the front matter, etc., to make that consistent. But then we came actually across a lot of inconsistencies in the chapters, and that was done by the typesetters. The typesetters actually took the freedom actually to revise text without actually using track change. And they were not happy to get additional index words, and we were not so happy with the automatic ending they had. And the text boxes were on actually very strange places and a bit mixed up. And we didn't, the equations was really a horror scenario because the management submission system couldn't really handle the equations, so we had to check every equation. So at the end, but that was more than half a year, Lena and me, we were very hard, working hard on this e-proof corrections, and we were happy to see the book published in September 23. And it is copyright 24. We don't know exactly why the copyright is in 24, but maybe that's a trick from Elsevier to keep us for longer on board and on the copyright. Okay, that's in detail the timeline.
Thanks a lot, Henny. And then we move on to the content. It's structured in 3 parts. The one we look at drought as a national hazard, providing the basic knowledge of the drought phenomenon. And these are the 3 chapters were similar in the first edition. And I will go through these as in a while. Then part 2 is related to estimation methods, providing contemporary tools and methodology, starting with simple and then going on to more advanced methods. And the last one is elaborating how human interacts with drought, including climate change and how we deal with impacts and forecasting and monitoring. I'd just like to say that some of these chapters, as the first 6 perhaps, are only moderated, changed. 7 and 8 had a major revision, and part 3 is more or less a new addition to the first edition. So part 3, Living with Drought, is basically the new content. As I said earlier, this worked example, all that is in the first edition was now available online on the EDC website. So for the second edition, it's provided on GitHub, and there's a link there. It's called Hydrodrought. And what's on GitHub, it's the data that will be presented by Henny in chapter 4. We have worked example where we go stepwise through the different methodology introduced, so that as a reader you can repeat these calculations either using the data set provided or your own data. We have self-guided tours for the more complex methodology that didn't fit to provide as a tool, but there's a PowerPoint elaborating the step-by-step way of doing it. And then we have supporting documents where the details included would be too much to have in the main chapters. And the supporting code is just for chapter 7. It's not a worked example, but gives you the script because we do some statistical properties calculated from random sequences from a time series, and then you can repeat this by using that code. Okay, so we start with chapter 1, and for each chapter we basically provide motivation, content, and key messages. As for drought, I'm leaving out key messages because now for the introduction, because it's not so relevant. So motivation for both books is we see that the global warming and an increasing demand for water have raised our awareness and our vulnerability to drought. It can affect all regions of the world. And very important, the characteristics and impacts will vary with region. So we more or less are familiar with the kind of droughts we experience in our region. And then we need to widen our horizon and see how it manifests itself in other regions. So this figure 1.3 is just, the black is the historical and red is current droughts going back to 2021. It's just illustrating that drought occurs in every hydroclimatic region. And these are the very major drought events with very severe impacts and casualties. So many regions seen this increase, and both in frequency and severity. As the climate warms, we get more evaporation, and it sort of makes a drought that would occur due to climate variability. It sort of increases its severity, has the potential to increase it. So we do see that these are changes that are projected to continue in the future. And we think it's very important from a sound water management to have a thorough understanding of the drought hazard. So the content of chapter 1 I have illustrated here the propagation of drought through the hydrological cycle. It sort of has its origin in a meteorological situation. Meteorological drought might propagate, become a soil moisture drought, and if it sort of sustain, can end up as a hydrological drought. And by that we mean both stream flow, groundwater, lake levels, and so on. And the focus of the book is on hydrological drought, but sometimes we need to include knowledge and indices that helps us understand the drought propagation. So in addition to introducing us to how hydrological droughts are developed, we provide an overview of international low flow and drought studies. It's not an extensive review, but we focus on community efforts and international collaboration projects and networks such as the FRIEND. And then also we mention some recent books on drought that can help the reader to dig further, also on topics that we do not cover. So we close chapter 1 with a call from the UNCCD in 2022 that we should all make a global commitment to drought preparedness and resilience in all regions of the world a priority. And this is sort of highlighting that this is an issue that will not go away, that it rather will enforce itself. Chapter 2 then takes us to the hydroclimatology, and its motivation is to explain the climatic context in which hydrological drought occurs across the world. What it provides is to provide an overview of the world's climate zone and hydroclimatic conditions, seeing this in the context of how a hydrological drought may develop and manifest itself. So that's what you see on the left-hand side, the Köppen classification, climate classification system. You see the first row of graphs is the climate, temperature and precipitation, the monthly regimes, and then you see a typical hydrological regime comes from these regimes. So understanding this seasonality is vital in order to do a robust drought analysis. We also discuss spatial and temporal characteristics of drought in these different regions, and very brief say how climate change interacts with drought in this region, but details of climate change impacts goes to chapter 11. Key message from chapter 2. We really need to understand a region's hydroclimate as a prerequisite for any drought study. A drought is a large-scale phenomenon, so it's created or initiated by large-scale atmospheric circulation anomalies. Very often these blocking systems, you can get some land surface feedback, and then you can have a hydrological drought developing. So it means we have large spatial and temporal footprint of hydrological drought, but distinct footprint will be different depending on the component of the water cycle you are studying. And that is the point here with the example from figure 2.7, where you see the spatial footprint of the meteorological drought index, the SPI 3, August 2015, where you see the center point of the drought stretching Central Europe towards the eastern part, very coherent spatial. And whereas you go to stream flow, low flow, in terms of return periods, you see basically the signal of the major drought. We didn't have data from the eastern part, but it's more variable, it's more diverse than the meteorological footprints. So you see particularly the Alps here, they were probably snow or glacier melting, or you benefited from the heat and had an increase of higher low flows. So what happens on the ground is very important in terms of the variability you see for hydrological drought. And there are novel attribution studies, and that they can sort of see to what degree a given drought is influenced by climate change, that its likelihood to occur would be this and this with and without climate change. Chapter 3, Henny?
The purpose actually of chapter 3 was to explore, or is to explore and describe how weather anomalies actually affect the different water components as they propagate through the hydrological cycle. The anomalies are the driving forces. The anomalies are the precipitation and temperature radiation affecting the potential evapotranspiration, so the water demand from the atmosphere, and also temperature affects, of course, the snowpack storage. And this is the climate-induced drought. The scheme, what you see is a little bit more elaborated from the scheme we have presented in chapter 1. And the focus actually of the book, and that's actually what you see in the brownish colors, is on stream flow and groundwater. A little bit lighter in color is the fluxes. So we, in the book, there's particular attention to recharge and the discharge from the aquifers into the streams. And if we look to stores, then we look at the soil and the aquifers. And the aquifers can be distributed or divided, subdivided in shallow ones and deep ones in some regions. And that finally ends up in stream flow. So these are the major water balance components. The next slide, Lena. The key messages of chapter 3 are actually there is an interplay of climate and catchment characteristics who actually govern the drought propagation, and that results actually in different characteristics like the frequency, duration, and severity. If you look to the left diagram, very quickly you quickly can see the horizontal line is a fixed threshold, and if you look then to the different diagrams, in the left column you see a temperate humid climate, and in the right column a semi-arid climate, and the difference between the upper and the lower row is the groundwater system. If you have a flashy one, so you have a clay catchment with very quick response on recharge, and the lower one is a very slow response. And very quickly you can see that in the areas below the thresholds are very different. So there is a difference which is actually determined by climate and catchment characteristics. What we also did in the book actually to classify the different drought generation processes and the associated drivers, we introduced a drought topology. Next slide, Lena. That's chapter 4. Chapter 4, of course, it's very essential data, very essential for drought and low flow analysis. What we described in this chapter is data types. So you need different types of data, obviously time series. We also need spatial data, and metadata are also very important. There is a chapter on the collection and the processing of the hydrological data, and also the hydrometric practices. So the points of attention are also mentioned there. So particularly if you try to monitor low flows of river flow and groundwater during low flow and drought conditions. And of course, you can't work on hydrological drought if you don't have supporting hydrometeorological data that was also presented in the scheme in chapter 3. So you need to have precipitation, evaporation, and soil moisture to understand what's going on in the soils and the groundwater system, and finally in stream flow. For data scarce area, it's really, for engaged situations, really important to realize that there is global and regional data, climatological, hydrological, physiographic, which can be very helpful if you are in a situation without limited data, that you can use this data for at least a first indication. And it's and finally, in chapter 4, a description of the example data set. That's the next slide, actually, giving some more information on these example data sets. They are in different scales. The first one is the left one is the international data sets from 20 gauging stations across the globe, across the world. There are long-term time series of daily river flow, and they differ from 30 years up to over a century. So the length is different, but they are really very useful if you would like to practice and to work with data. The second one is a regional data set. We selected the regional data set eastern part of Austria. So there's 30 catchment, that's a subset of a larger data set of Austria. There's time series of daily flow data. There is a data set with all kind of annual and seasonal low flow indices, and there are climate and catchment descriptors, 31 of these descriptors, which are very useful if you are working on regionalization. Come back to that in chapter 8. And then we had two local data sets. One is an extended one that is from the Upper Guadiana. The Guadiana is a catchment, a river basin in southern Spain, semi-arid climate, and we collected data, their time series of weather, groundwater, and river flow data from several locations. So particularly if you go into the detailed modeling, the detailed analysis, these local data set could be helpful. And then for groundwater, we had one particular one at the Stoner Park well in the UK, a little bit west of London, and that's a very long-term time series of groundwater data from the Chalk Aquifer. The key messages of the chapter 4 is you need different type of data if you would like to have a thorough understanding of the drought phenomena. You need additional data. Additionally, you need also to take care about the data quality and the management. So that's critical steps is not only collection. And then the global and regional data sets can be helpful in data scarce area. And as already mentioned by Lena, and the example dates are available on the GitHub. And I saw that Bastian already provided the link in the chat. Next slide, Lena.
Then I take over. Now we're moving on to hydrological drought characteristics and the chapter advice how to define drought and how to decide on the hydrological drought indices best suited for your study. So it provides an overview of different characteristics, also the terminology used. And we separate into low flow and drought deficit characteristics. And the latter, the deficit characteristics, are then identifying using a threshold level, as exemplified in the figure to the left, where you in the top A row see a constant threshold being used, whereas in B, a monthly threshold is being used. So the main awareness here is to think, do you want an absolute low flow or drought related to absolute low flow values, or do you want to see anomalies in as a seasonal aspect? If you do see it as an anomaly across the year, you must be aware that you might detect drought events in a wet season as long as if the water level is or the stream flow is less than normal. This might not be what you want, but you need, if it is, you need to be aware of how it can impact your analysis. So it's very important to distinguish between absolute values, absolute low values, and versus anomalies. We also introduced the standardized drought indices, which really stems from the meteorological community with the SBI and SBEI. We do comment on those, but we also focus on the hydrological one, including the standardized groundwater index, and discussing pros and cons in different contexts. There's also these multivariate indices we distinguished into modeled and combined. Model being you have a set of variables that you combine using some modeling into one index, whereas a combined index keeps these variables separately and then weight them differently. And then we also discuss or give some examples of how we can quantify the spatial aspects of drought. So in the figure here, 516, we see an example of such a combined drought indicator, the CDI, that is used by the EDO, the European Drought Observatory. It combines a shortage in precipitation and soil moisture and use satellite information regarding the vegetation production. And then it can also be linked to a stream flow drought low flow index derived using a threshold level method. So the key messages for chapter 5, we can't agree on one universal hydrological drought characteristics or index because it wouldn't fit all applications. You have to make the choice based on the problem under study, the kind of regimes you are studying, and the kind of data you have available. you need to, a lot of the method we present is for perennial rivers. They don't run dry. So we also introduce what is called no-flow indices for intermittent or ephemeral rivers that do run dry every year. And we also separate between flux indices derived for fluxes versus state variables. And that is also important when you decide what kind of index to use. I would like to highlight the seasonality is super important to be aware, because if different processes are causing low flows or drought in different seasons, they're caused by different processes. In statistical terms, you have to handle these separately. So come back to that. And then if we characterize drought using different indices, we might derive very different conclusions for the same region or data. So awareness about this. Chapter 6, motivation is to give a statistical background to frequency analysis for hydrological drought application, including at-site and regional procedure. So it provides a step-by-step introduction to frequency analysis for low flow and drought characteristics, focusing mainly on streamflow. We apply it to time series, highlighting methodology concerns. We give an overview of probability distribution commonly used in frequency analysis for hydrology, and we add in some example of mixed distributions. Say if you have strong seasonality, summer and winter low flow, how can it be represented through a mixed distribution? And briefly touches upon approach for non-stationary frequency analysis. What I show here on the figure 614 is annual minimum 1-day values. It's reduced variate scale here for exponential distribution. So if the data fit exponential distribution, it will follow the straight line. Plotted also is the 2-parameter variable distribution, and it's clear from the data, which are the observational points, that in this case, the variable distribution is a far better choice. So in terms of key messages, here is the list of probability distribution that we go into details with, and they will be fitted for AMS, meaning annual minimum or maximum series, PDS, partial duration series, or a combination. And we give very detailed overview of their properties and mean and standard deviation, skewness, etc. in the appendices. So key messages: the reliability in any design estimate depends strongly on sample size and the degree to which the idea assumptions are met, meaning the data should be independent, no trends. It should be identically distributed, meaning caused by the same processes. If we have limited data at site, the use of regional information reduces the sample uncertainty, and then it further allows estimation at the ungraded side. We do this for streamflow. And when we choose a distribution, it should not merely be chosen based on the fit for a sample, because it comes with limitations, but it should be based on knowledge on the phenomena studied and the theoretical base of distribution function applied to extreme value analysis. That is, you should do the general extreme value distribution for annual maximum series and the general Pareto distribution for PDS, and the motivation is provided in the chapter. Chapter 7, statistical analysis of drought series. The motivation is to introduce the reader to statistical background for many of the drought applications found throughout the book, and really highlighting their assumption and limitations when applied. It's super important. So it provides an introduction to stochastical hydrology, including how to account for non-normality, seasonality, and autocorrelation. It gives a background to regression analysis, starting simple to more complex model. It has a very nice section on troubleshooting using residuals, trend and structural change analysis, exemplified by the figure here, where these are the annual minimum flow 1 day for the Göta River in Sweden, and it's very clear that is a break point here, and you can identify through statistical analysis, and this was due to a change in the management operation at this time. Also, some spatial temporal techniques are provided, like correlation and composite analysis, PCA. And I should mention, because I saw Jim Sturgey online, that he's the main lead author of this chapter. So the key message for this chapter, it providing the underlying theory by noting assumption and limitation is important in order to properly apply any statistical technique. The chapter was designed from a practitioner standpoint, so give you a very detailed introduction to understanding and accurate apply a technique. And the more advanced techniques, then there is a nice list of further reading recommendations. Figure here gives you, we have the same Göta River, but we start in 1940, avoiding the breakpoint, and just show how the field sense slope trend line is here. It's a non-parametric test as compared to the linear regression trend in this dotted line. I'll give the word to you, Henny.
Yeah, motivation of chapter 8 is the estimation at the ungate site. So if you have little data, then regional procedures could be really helpful to get at least an estimate of low flow or drought characteristics. The chapter gives the main statistical approaches that traditionally are used for low flow, but in most cases also can be used for drought indices as well. And there is a survey of studies, and that's in the second bar, that demonstrate the application of these key visualization messages. At the left, you see an example, actually, that's two approaches compared. That's on the standardized Q95, so it's standardized by the area. You see a particular river in eastern Austria. And it's the top green to the left and a regression multivariate analysis to the right, and you can quickly see the colors. The lighter the color, the better the performance is. So you can quickly see actually differences between methods. So that's what you can read in chapter 8. The key message of chapter 8 are, next slide later, key messages that the regionalization techniques allow estimation of low flow and drought indices are engaged sites. Multiple regression is what you often see. It is most commonly applied, but of course we have challenges if you look to heterogeneity in the processes. The outliers are an issue, and the collinearity of the predictors. If you use geostatistical methods like top kriging, then you actually are looking at you exploit the spatial correlation of the low flows. A major challenge if you use the top kriging is nest structure. So, for instance, if you look at a particular catchment, and there's also the headwater, so you need actually to distinguish between sub-catchments within a larger catchment. So that's an issue. And then if you have really limited data, then sometimes short time series, so 1-2 years, can really be helpful to add to the few time series you have. Or what you also can do is to go at one particular time to the field, to an area, to a catchment, and do a lot of measurements, particularly at the time that the low flow actually is there, or the drought conditions. We move on to chapter 9. Chapter 9 actually provides an overview of process-based models. We distinguish two categories, the hydrological models and the social hydrological process-based models. If we look at the hydrological models, then we describe actually the two different groups, the spatial lump models. And a well-known example is the HPV model, as it is used in some cases. Then the catchment actually is represented by one cell. And on the contrary, you have the spatial distributed models. There you actually distinguish different cells in a catchment, where you can actually then allocate different land use and different soils, different aquifer characteristics. Spatial distributed models can, if you go to the more comprehensive ones, you can also account for groundwater flow in a sense that you look at head differences, so that you go into the really the complicated, comprehensive distributed models. To the right, you see one example of an observed stream flow. That's figure 9.5 as part of the figure. And then you see in blue the observed recharge, and in red the simulated recharge, and there is some noise, so that is taking care of the uncertainty. Social hydrological models, actually they account also for human behavior, those are feedbacks, and means there are top-down models. Top-down models, an example is the coupled component models, the system models. They actually give a kind of a very generic description of human behavior, and the other one that's basically starting more at the behavior of individuals. That's the bottom-up model, and the typical example is the agent-based models. What we also do in chapter 9 is adding information about uncertainty, and we give guidance how to select the process-based models. Next slide. Okay, if we look at the key messages if you would like to understand more of natural drought generation process and the influence of human intervention, chapter 10, but it also applies to 11 and 13. Actually, then you can use these process models. At the right, you see one example. That's a social hydrological model. And what you can see there in the boxes, the upper boxes, you see typically hydrological components, but at the bottom you see a water demand component. So there's a water demand to the surface water and groundwater, and means that the water demand can be limited through because of the lower stage in these two reservoirs. Process-based models can also be very valuable and often used to extend your hydrological time series. You have a very shorter period of this observation, you calibrate and validate your model, and then you extend the time series. And if you look to the selection of the model, that's the last one in the key messages. Then is the data availability is, of course, it's an important one, but also actually the practicability is as a user you need to understand actually the model. The software package, sometimes there is budget involved, but also the purpose of the study. Sometimes there's limited time to do your study, so the selection of your model should be then depend on that. Guidance in this chapter is provided. Chapter 10 is actually about the key message about understanding. If you look at chapter 10, there's the human influence, and it's very clear that droughts influence people, and also the other way around. Actually, people actually try to be prepared, so they try to alleviate influence, and they take measures. There's the interventions we actually describe in the book is water abstraction, surface water, groundwater, reservoirs, land use, forestation, deforestation, and drought management. And the procedure we use, that's what you see in the diagram. Usually you have a human influence discharge, so you try to naturalize that. You take then the threshold, the variable threshold, as explained by Lena, and then you confront both hydrographs with this variable threshold, and then with what is indicated with red, and you find the droughts. And then you can make a distinction between climate-induced droughts, human-induced droughts, so they're only caused by human interventions. You also have the mix that you have the human-modified drought. So the couple of procedures are mentioned in the book. They are catchment scale, so observation-based, and the second category is scenario model and scenario modeling, and there's another category of the social hydrological modeling. And as in chapter 9, there is a chapter on uncertainty. Next slide.
I think, Henny, we need to skip the examples at a matter of time.
Okay,
okay with that?
Yeah. Key messages. People can both elevate and aggravate the hydrological drought. Is very obvious. You need to have different approaches also because of the availability data and the scale. Social hydrological models can be very useful if you are interested in how people actually interact, and of guidance is provided. Next slide. 11 is about the past and future droughts. Important to mention actually is that if you would like to study future drought, it's really important also to look at the past. So it should also not only interested in what happened in the future, because a good understanding of historic trends allows you to have a deeper understanding and better insight what will happen in the future. So droughts need to be actually investigated. That's the main important message or motivation in this across time. So from decadal to centennial scales. So we have different periods. We have distinguished a distant past, so it goes back to the 15th century. Instrumental period is obvious. Then we have observation, particularly from the last century. In the future, then we only have, of course, projections. So we completely rely on models. To the right, you see one example for the distant past. So that's for a river in the US. Then those ski rings were used as proxy, and then you see a reconstruction of the base flow, and then you see particular low base flow around the early 19th century, so around 80-20, but also in the 1970s you see very low base flow. So this is a way actually to look at climate variability in the distant past. Next slide. Is the key messages. It's important to study this hydrological drought, as I said, across time. So do you understand the historic and the future climate variability? The processes actually you should understand, and what are the dominating trends. So not only rely on a projection of a GCM. So you see one example to the right. It's a global map, and basically saying in blue for the end of the 21st century, in blue that it likely will become wetter. In terms of river flow, in brown is likely will become drier, and that's the effect, the simulated effect of human interventions and climate change, and that's reservoirs and human water use. We have different approaches needed by definition. If you look at the different peers, proxy data, observations, modeling, and by it's certainly also relevant to use long time series. Okay. Next slide. We jump over 12. Lena will do 12. So I will go to the last chapter book, chapter 13. And that's about drought early warning systems. So the chapter provides aspects of such a drought early warning system. Important actually is to look at concepts. Who are the target users? Lena already mentioned indices, so you can come to different conclusions depending on the purpose. Also, your scale is important. Then we dig in sections in the monitoring and the forecasting, different approaches. Forecasting, we also look at the uncertainty. And an important aspect of the drought early warning systems are actually how effective they are and the dissemination. So the contact with the target users is really important. So try to engage them from the beginning and try to engage them in the evolution. And maybe they would also like to have a kind of an ownership. And the drought early warning system, that's what you can see in the diagram, are actually part of a broader concept. That's the drought management plan, and drought management plans actually should be part of a larger integrated policy and land and water policy and associated plans. The key messages of chapter 13. So monitoring and forecasting relies on observation and models, and preferably multi-model platforms should be used. That's very common actually for the meteorological ensemble, that we have meteorological ensembles, but also preferably hydrological ensembles should be used. I'm not so sure if that already is used in an operational sense in research project that has been done. To the left, or to the right, sorry, you see such an example of a global forecast 4 months ahead in 2019, January. And in brown, you see a kind of you see the forecast actually that the flow is getting lower, and in blue the flow will get higher in 4 months later. That's the forecast. This is, and you see it instead for Central Asia, there's the River Congo in Kinshasa. As already mentioned in the description, the content of the chapter, it's really important to engage the target user. So that's a key message, that don't develop it without having a target user on board, and address and communicate uncertainty. Lina, it's your chapter.
So then the last one before 13, and 13 was the last, and it's about drought impacts. And motivate and aim is to offer a methodology guidance on how to classify, analyze, and use impact data to quantitatively linked impacts to drought indices. It provides a framework for classifying impacts. It present different options for how to collect impact data from qualitative and quantitative sources. It's a guidance on how to analyze these data to better understand the diversity in drought behavior. And there is an example of how to link quantitatively the impacts to the indices. And on the left-hand side, you see an example of different drought impact categories collected for the River Rhine in the period 1950 to 2018. The classification system here, where these are the sectors, I think there's about 12 of them, and then you read and collect reports and published information, and then you make a database of the impact. It's very time consuming, but it's needed in order to make an analysis that really have all the data and all the kind of impacts embedded in it. So it's very often a community effort, and it's time consuming, but indeed very valuable. So key message, knowledge on drought impacts is crucial to develop sound drought management plans. There's a strong need for impact data, but availability is limited and standards for collecting these are lacking. There are some efforts now, as I mentioned, the former one, which was this impact database, was called the EDII. It's now recently published in 2026, a modification of that called the European Drought Impact Database, and there's a website. So things are happening in terms of standardizing classification for drought. An impact database will allow you to map spatial and temporal visualization and summary for in general, but for a given drought event in particular. So if I have information on impact, that would help me select a drought indicator or indices that is valuable to the users. It's no point in using a drought index that does not relate to impact, because we are basically interested in the impacts. So trying to see whether this index relates to impacts is super important. And an example is here to the left, where you have here a meteorological drought index, the SPEI3, and then you have collected impacts, non-impact or an impact, yes, no. It's an indicator value, and you derive the likelihood of an impact as a function of the SPEI, and you see there's a much higher likelihood for negative SPEI3 values. So that's one way, and you can use also this to predict impacts in the future. So coming to the end, what did we learn from putting together the book? What is the key messages as a book as a whole? We think the way it is written, it's a textbook style synthesis, not a review paper. About hydrological drought, it will be useful for newcomers in the field and provide a reference work for drought experts. It spends quite a lot of space on assumption uncertainties of certain methods and tools, because these are vital to avoid ambitious conclusions. And we provide work examples, so you could practice a suite of methods and tools on your own data, as mentioned, also the data including. And then if we sort of decide on a more common framework and common indices that will support comparative analysis in the community, We were really benefiting from a broad team of contributors and a strong coordination. We really, if you're open to it and can receive criticism, constructive criticism, you really get a better product. Finally, this very hard communication and time-consuming communication with Elsevier, retrospective, perhaps we should have just made an electronic version ourselves. That would also be much more beneficial for the community. That's a go looking back. So thanks to all the contributors. Some of them, lead authors, are here, and all co-authors, and to all of those listening to our presentation going a little bit over time. Thanks a lot for your patience.